Hello, and welcome to part 2 of what I've learned so far about event sourcing in a microservices environment. As we've said in the previous video, the presentation is most suitable for developers with design experience, particularly in microservice environments. And we've created this presentation because when I started looking into communication between microservices and event sourcing, I found a lot of contradictory information and differing opinions. So this is a distillation of everything I've learned from sources that I came to trust and subsequently put into practice to prove that it works. You may have already watched part 1, covering the basics of CQRS. This 6-minute video covers the basics of event sourcing, and the following presentations show a common architecture and how to handle concurrency, then a demonstration of event sourcing in practice, including a note on choreography versus orchestration. Now onto event sourcing. Often, data is modeled according to the nouns of a system. For example, a bank account may be concerned with customer and balance. But, in this scenario, this is likely to be too simplistic, as most of us care about how our balance got to be what it is. Event sourcing seeks not to store the nouns of the system, but the actions of a system. For example, rather than storing the final balance, we store the different transactions on the account over time. Now we are saving events, rather than state. The read side must interpret the stored events to create views. We can have an infinite number of views, each one of which only interested in their own events. For example, a balance view might only care about money in and money out, whereas a view that's looking for potential fraud might only care about money out events. Incidentally, a common place where you might find event sourcing in use is in banking, where an audit trail is required. Although auditing can be achieved without event sourcing has the ability to replay the state of the system at any point in time. Events don't happen without an external input, a command. Commands are a request. Depending on the state of the model, they may be rejected, whereas events are in the past, the thing has happened. A mistaken event can be compensated for with a new event. For example, a mistaken withdrawal can be corrected by a new credit, but the past event cannot be changed. The event stream is immutable. Commands can trigger just one event, but they often trigger multiple. For example, the second withdrawal sends the account overdrawn, which triggers another event, the fine. Then, an external process which is monitoring the events of the account for suspected fraud thinks it's detected fraud, and so sends the command to suspend the account, which triggers another chain of events, such as suspicious activity detected, fine revoked, and then finally the account suspended. As the view is responsible for interpreting the event stream, infinitely flexible view models can be created. For example, a customer may be unlikely to see the mistakenly applied fines, just as suspicious withdrawals and the fact that his or her account has been suspended, whereas a bank clerk may see all the events. But because it's no longer as simple as reading the results from a table, we have to interpret past events to reconstitute the result. There is an additional development cost. So let's take a look at a typical architecture for event sourcing. Obviously, you can do it how you like, but this is a common example. It all centers around the aggregate root, that is, the domain model, for example, a bank account. First, a command is received by the command handler. Then, the command handler retrieves the past events from the event store for that aggregate root, or bank account, identified by a unique ID, such as an account number. The command handler then creates a blank aggregate root, or bank account with no transactions. And the command handler then sends the past events from the event store to the aggregate root. The aggregate root then applies the events to itself. This is called rehydration. Now we have a domain model in the correct state, or a bank account that's had all its previous transactions applied. It's worth noting that for the purpose of rehydration, it makes sense to store all events for a specific aggregate root in one stream. We could distribute them across different stores and aggregate them, but this would add very complex development and processing and communication overhead. The command handler now sends the received command to the hydrated aggregate root. The aggregate root handles the command and creates events according to its current state, or rejects the command. The new events are then applied to the event store. As the events are generated, they are applied to the aggregate root to mutate the state. Because the aggregate root is rehydrated only from events, no mutation can occur from a command, only from the events generated as a consequence of the command, as the command would never be received again. It is the event store that forms the bridge between write and read, or command and query, maybe via additional streams or projections, or just by reading the same database. but it is the event store that forms the bridge. The views just subscribe to the events they are interested in. For example, the account view subscribes to all money in, money out events, whereas the fraud view might only be interested in money out events. And that, in essence, is event sourcing. So a common question we've received about event sourcing is, what happens if I've got thousands of events? If an event stream has so many events that retrieval from the event store and rehydration takes too long, then a snapshot is usually the answer. While the event store stores events, each one representing an incremental diff of the aggregate route, such as a transaction on a bank account, the snapshot stores the state of the aggregate route at a point in time. So rather than replaying all events from the beginning of time, we load the state from a snapshot, which jumps us ahead in time, then rehydrate using the subsequent events. So the snapshot must also record the position of the last event in the event stream, so we know where to start rehydration from. If you have any more questions, please feel free to email me directly or get in touch with Triad via the links shown. Up until now, we haven't mentioned concurrency. As luck would have it, we've got a short video for that, and I hope to see you in part 3.